For this section, we will concentrate on removing items from a set. So again, the set notation, as we can see here, so we have a set variable and followed by an equal sign, so we're assigning it these elements. And remember, if it's a set, then it will have curly braces. So the delineation is done with curly braces. So we've got these elements in here, and we would like to investigate how the remove method works, the discard method works, what's the difference between the two, and how to use the pop method, which will also remove an item, but it will allow you to capture that item into a variable. So the pop method will actually return that element to whatever variable you want to assign it to. So we'll leave that to the end. Let's go ahead and get started with the remove method. So let's go ahead and try to, for example, remove -2 out of this set. Okay, so the way to do it is you actually reference to my set itself, and with the dot command, you have access to the methods that you need. So we're going to do the remove here, and we're going to tell it exactly what is it we're trying to remove, -2. Now, I would like to print my set, so print my set right here. Oops, let me just put a P here. Okay. And prior to that, let's go ahead also and print my set before we removed anything, so we can actually see the before and after while the program is running. So print, and again, my set. Okay, so let's go ahead and run this. As you can see here, prior to that, we had all these elements. Now remember, this is not an ordered list, especially because it is a set. So anything you put in whatever order you put them in here, you're not guaranteed to get the same order once you're outputting. Okay. However, -2 was removed. No problem. Now let's suppose we wanted to remove something that doesn't exist, like -1. Okay. Let's see how this application will respond. As you can see here, we get a key error that means that the actual program crashes. So it doesn't know how to handle, with a remove method, something that does not exist. Okay, so let's put a -2 there for now. So we know that's going to happen. How can you handle it? Well, we can do some exception handling. We've seen that, how it's done. We'll do an example like that in a minute. But prior to that, let's go ahead and do the discard and see what the difference between it and remove. So on the surface, they look like they do the same thing. So let's go ahead and discard car out of the list. So we're going to go ahead and do my set dot, and we have access to discard. So I am just going to go over here, and we're going to say car. Okay, so car as a string, and then print my set. So everything so far, in terms of what we want to remove or discard, are as our existing data members of this set. So let's go ahead and run this. And you can see here as we go down, we not only lost -2, but we also lost the car. So on the surface, they look like they do the same thing. Now let's suppose I want to remove -1, which we know does not exist, with the discard command. Let's see what happens. And notice the program does not crash. So if you want to remove something and you don't want the program to crash, you could use discard. Otherwise, you're going to have to use some sort of exceptional handling with the remove method to handle this. So discard is pretty safe, but the end result is pretty much the same. Let's go ahead and do an exception handling quickly with the remove. So I'm just going to remove these two here. We don't need the discard. We know it works just fine. And we're going to try these two. Okay. And we're going to do except. We're going to print some sort of an error in case there's something wrong. Print and no such item. Okay, so right now, and let's go ahead and let's see if it will print my set. And sure enough, it removed -2. Now let's go ahead and remove -1 now. And let's see what happens. No such item. Okay, so it's pretty cool. So it catches the error before the program crashes, right? So this is good review for exception handling. And then obviously we get no such item. Okay, so the set itself will be intact. Good. So now let's talk about the pop method to conclude this part. So let's go ahead and print my set again. Okay, so let's run this. We could see the set right here. We're going to do a pop. Now pop returns the element. So maybe something like this: item equals my set dot. We're going to do pop method, and we're going to pop simply like this. Let's see what happens. And let's go ahead and print item. Print item. Now, usually when you're popping out of a stack, you're going to take an item out from one end or the other. And let's go ahead and print my set. Okay, so let's see how this behaves. And notice it popped the orange out, right? And then the set had no orange in it. Okay, so let's run this again. And again, notice because the initial order is what counts. 7 is what it popped. Before that, we popped the orange. So every time you run this program, you're going to get a random popping of the first element. So this is first in, last out that you put in here, right? So, but remember, as you run this program, you're not guaranteed to get the same list. Notice Apple now is the first one, and Apple is the one that gets popped. And that's because you have an unordered list here, or the elements of a set are unordered. So you're not guaranteed a specific order because they're not indexed. Okay? We've seen you cannot use an index to access them. So, but with the pop, however, it's nice because if you're popping, you're actually storing the item you're pulling out, right, into a variable. Then you can do whatever you want with it. Okay? So in our case, it popped the apple. So we're ending up with a set that does not have apple, but we still have apple stored in item, and we can do whatever we want with it. All right, so we're going to do more set exercises coming up and conclude sets from there. I will see you again.